Hi, I'm John Snipes, and this is my submission for the Week 3 homework for SCM 519 Analytical Decision Modeling 2. This week I chose question 52 out of Chapter 10, and with this particular question, we're tasked with figuring out, does it make sense to have a schedule to replace light bulbs, or just let them burn out and replace them as they do? So I'll go ahead and go to my model here. We have our inputs. We have 1,000 light bulbs. I'm just going to run 1,000 iterations. We're going to model just one particular socket. And then T is our time. For this case, we're doing 3 months to start with. It tells us in the problem we have a 5-cent replacement cost if we plan it, and a 20-cent replacement cost if it just burns out and then gets replaced. We don't know the cost of bulb. I'm just assuming it's 0, but that is something that is not given to us and may factor into our decision making. We don't have a distribution for what the lifetime of a bulb should be. We only know it's at most 5 months. I took that to be a triangle type distribution, and I picked most likely a 4. Again, we're taking some guesses on this one, so this could all be easily changed. I ended up doing 2 models for this. We'll talk about Model A first, and then I'll talk about Model B. So Model A is, I'm assuming they've got some kind of logbook, or however they keep track of these, but after it gets replaced, they're going to either allow that particular bulb to burn out, or they're going to replace it in T months. In this case, we've got T as 3. That's our Model A. And so the things we did is we tracked the bulb life, and then use an if statement to see if the bulb life is greater than T. And if bulb life is greater than T, then it gets replaced at T. So it'd get a 1 to confirm that it's a routine replacement, or it would be a 0 if it burn out. Then we're going to keep track of cumulative time. That's going to be the minimum of our T, or the life of that bulb. And I'm going to just keep track of our bulb count, how many bulbs we're using, and then our cumulative cost. And again, this is factoring into if it was a routine replacement, it's going to be 5 cents. And if it was not a routine replacement, if it burned out, then it's going to use the 20 cents. And then I have 1 year. And basically what I'm doing is I'm tracking a socket. Each bulb socket for 1 year. How many times does it get to be replaced? And what's the cost to replace the bulbs in that socket over 1 year's time? And so we know our time's going to be less than 12, so it's going to be 0 for these first couple columns. But then once again into column 3, it's using an if statement, and it's just saying if our cumulative time is equal to 12, and it's the first one and the only one that equals to 12, or greater than 12, then it gets a 1. When we get into our second rows of this, we had to tweak our formulas just a little bit. Cumulative time is just adding cumulative bulb count, cumulative cost. So this one was fairly straightforward to set up. Model B is over here on the right. I set this one up just a little bit. I figured you've got maybe sections of a building, and you're going to replace this section every 3 months, whatever that interval is. And so at that point, it's whether it's been replaced in the last routine replacement or whether it got burnt out in the meantime, it's going to be replaced at that interval. So for this one, we're using a similar thing. We're looking at the life of the bulb and using that to see if it's a routine replacement. But then I also want this value here of the time to the next replacement. And then we're going to keep track of cumulative time, cumulative bulb count, and cost. And again, the same thing here. Once we get to 1 year, that's the values that we want to use. I ran the simulation once. Since we're trying to figure out, is it more costly to have a schedule or to not have a replacement schedule? I just ran it with time of 6 so that everything's just going to burn out and get replaced. So this is sort of our average, and we're tracking the number of bulbs that are used and the price. I thought bulbs used might be important. We're figuring cost, but I don't know the company. Maybe there's a value for the environmental impact of the bulbs. Some of these bulbs can be bad for the environment. So maybe they want to sort of weigh what makes the most sense. Maybe it's more economical, but we're going to go through a ton more bulbs to replace it at 2 months, for example. So maybe they kind of want to find that sweet spot. Thought it might be a good thing to track. So if we use time of 6 months, again, just letting everything burn out, you're going to use an average of about 4.5 bulbs and an average of 91 cents to replace the bulb in the socket for 1 year. All right, so now we're gonna try for every 3 months, and we're gonna go ahead and run the simulation. Okay, we've got our distributions for bulb use and replacement cost. I'm going to pull up the summary results so we can just compare everything here. And we have our Model A outputs and our Model B outputs. We've got our min and max. So for 3 months, we're using 5.2 with Model A bulbs, using about 5.9 for Model B. We have an average replacement cost of 61 cents with Model A and an average replacement cost of 58 cents. Right down here we can see how that compared to 6 months or no replacement schedule rather. And again, the average price was 91 cents. So that's a pretty significant savings. The number of bulbs is also up. So if that's something that they're really concerned about, depending on bulb price or bulb environmental impact, that's something that they can also review. Thanks for taking the time to listen to my homework.